All right, today we're going to pull back the curtain on something that's all around us, but we barely ever notice it. Control circuitry. I mean, this is the invisible intelligence, the secret sauce that makes our modern world tick. And trust me, once you see how it works, you are going to start noticing it absolutely everywhere.
So, it all starts with a really simple question, one we probably don't ask enough. How do our devices, know what to do? I mean, really, how?
Think about your coffee maker, right? How does it manage to brew that perfect cup every single time just from you pressing one little button?
Or what about cruise control in your car? How does it keep you at a perfect steady speed, even when you're going up and down hills, without you ever touching the pedal?
And your camera. How does the autofocus make all those little tiny adjustments in just a blink of an eye to give you that perfectly sharp photo? It all feels a bit like magic, doesn't it? But it's not. It's just really, really clever engineering.
Okay, so behind every single one of those things, the coffee, the cruise control, the camera, there's this one single, really elegant idea. You can think of it like an invisible brain that's making all the decisions. So let's dive in and see how it works. So the technical name for this brain is a control circuit, and that's exactly what it is. It's the decision maker. It's the part of the system that takes in information, figures out what to do, and then sends out the commands. It's basically the central nervous system for any machine.
So, the big question is, how does this brain actually think? Well, the best way to wrap your head around it is with something we all have in our homes, a simple thermostat. It's actually the perfect example of this whole idea in action.
Okay, so every control circuit, no matter how complicated, is really just doing three basic jobs. First up, it has to sense. For your thermostat, that means it's using a little thermometer to measure the temperature in the room. Job number two, it has to compare. It takes that temperature it just sensed and compared it to the temperature you actually want, the one you set. And finally, job three, it has to act. If the room is too cold, boom, it tells the furnace to kick on. If it's too hot, it fires up the AC. That's it. Sense, compare, and act. It's really that straightforward.
And that whole process we just described, that's what we call a feedback loop. And this is the key to everything. The system does something, then it senses the result of its own action, and that information feeds back into its next decision. This right here is the secret to pretty much all smart automation.
Okay, so once you grasp the idea of a feedback loop, it kind of unlocks the next level of understanding. Because you start to realize that not all automated systems are created equal. They basically fall into two big categories.
On one side, you've got your closed-loop systems. These are the smart ones, right? Like our thermostat. They use that feedback to constantly check their own work and make corrections. But on the other side, you have open-loop systems. These guys just run on a preset plan. They do their thing and that's it. They never actually check to see if they got the result they wanted.
Let's make this super clear with a couple of examples. An open-loop system, think of a basic toaster. You set a timer, you push the lever down, and it just runs. It has no idea if your bread is perfectly golden or a charcoal briquette. It just runs for the time you told it to. Same with a simple time sprinkler. It'll turn on even if it's pouring rain outside, because it's just following a schedule. Now, a closed-loop system, like your cruise control, is totally different. It is constantly measuring your car's speed and making tiny adjustments to the engine to keep it exactly where you set it. See the difference? It's all about that feedback. Okay, so now let's zoom out a bit. Because this really simple idea, the feedback loop, is the fundamental building block for our entire automated world. It scales up from the simplest little gadgets all the way to the most complex machines humanity has ever created. And I mean, you find them everywhere. They're in your washing machine, making sure the water level is just right. They're all over your car, managing the engine performance. They're the reason industrial robots can do these incredibly delicate tasks with a precision we could only dream of. And yeah, they are absolutely what guides rockets into orbit.
And hey, to really drive this home, get this. A modern car has over 40 major control circuits. We call them ECUs, or electronic control units. Every single one is its own little brain, running its own little feedback loop, controlling everything from your power windows to how your airbags deploy in a crash.
And that's really the main thing to remember. These circuits are kind of like the unsung heroes of our age. They are the silent, tireless workers in the background that take our simple instructions like, I want it to be 72 degrees in here, or let's go 65 miles an hour, and turn them into precise, reliable, non-stop action.
So that brings us to a really interesting thought. As these control systems get more and more powerful, evolving from simple circuits into really complex AI,
It leaves us with a pretty big question to chew on. As the machines we build get smarter and better at making their own decisions, which decisions should we always keep for ourselves? Where do we draw the line that should only ever be crossed by a human hand?